Alright, let's continue to do more of these derivative exercises where we're using sort of a strange subset of tools in order to solve these derivatives, but it works. So anyway, so here we have f of xy is sine of x times sine y, and so here we just go ahead and we replace x with pi 1 and y with pi 2. So what we're doing is this is pi 1 of the vector x comma y, and then pi 2 is pi 2 of the vector x comma y. And that's all we need to do in order to put it into a form that we can sort of attack with the tools we have at our disposal. So again, we have df, and we're going to evaluate the point AB. So this is, first we have the derivative of sine evaluated at pi 1 sine pi 2. Then we're going to multiply by the derivative of what's on the inside. Again, this is because of the chain rule. Okay, now the derivative of sine is cosine, so we have cosine. Then everything on the inside we can switch back to what we have, or switch back to using variables instead of these projections, because we don't have to take any more derivatives. As for this other term we have to use the product rule. So we take pi 1 prime times sine of pi 2 plus pi 1 times sine of pi 2 prime. Okay, so again, this is going to remain cosine A sine B for the remainder of this. And now we have, let's see here, so pi 1 prime, it's going to be 1 comma 0. Then sine of pi 2, we can go ahead and replace this with sine of b. And now we have pi 1, we can switch that to a. Now when we take the derivative of sine of pi 2, it's going to become cosine of pi 2. Here, I'll just write it out. Instead of breaking it up into two steps, you use the chain rule here and you get cosine of pi 2 times the derivative of the function pi 2. And so this is going to be cosine A sine B times, and now we've got, so this is sine B comma 0 plus, now we've got A cosine B times 0, 1. So what this is going to end up with is we're going to have cosine A sine B. And now we've got, when we add these two together, because of the 0 in the second term, the sine b is left by itself. And then because of the 0 in that first term, we get a cosine b. Okay, so I guess we don't need that extra parenthesis there. We can move all this over a little bit, and then we should be able to wrap this up. I'll give myself. You don't need to do this final step here, but I'll go ahead and do it. So this is sine of b. Here, I'll write it. Cosine of a sine b times sine b. Then we've got cosine of a sine b. Then we have a times cosine b. Why did I write so? It's some sort of combination of sine and cosine, but it should be cosine. Okay, so that's part C. That's all we need to do for that. So now we move on to part D, and here we have f of x y, z is sine of x sine of y sine z. Okay, so this is sort of just like another step. So now what we're going to do is we're going to let g of x comma y be sine of x sine y. So this is the same thing that we had from part C. And so this is the function g, and we also know the derivative of g because we can just use part C to help us. Okay, so now that we have this, we can write f of x, y, z as we're going to use g to help us to sort of like do some of the work for us. So this y sine z on the inside here, well, this is, let's see here, so we have sine of x times, well, sine of y sine z, that's the same thing as g of y comma z. And now we can replace x with pi 1 and y and z with pi 2 and pi 3 respectively. So now, just keep in mind, this isn't necessary. You don't have to do this problem this way, but because the formula in part... Wait, why do we even... Is there anything else we could do here to simplify this? So it's sine of something, sine something. Sine of something, sine something. No, I think this is the most we can use a part. This is the most we can apply part C, I think. So anyways, we have f in a formula now that will make it a little bit easier for us to oh, whoa, that was way farther than I wanted. Okay, well, anyways, so now we can deal with f a little more easily. So now we take the derivative of f. And again, the derivative of f is going to be evaluated at a comma b comma c. I'm not going to write that so as to save myself a little bit of room. So let's see here. So we're taking the derivative of sine of pi 1 times g of pi 2 comma pi 3. So chain rule, we take sine prime of pi 1 times g of pi 2 pi 3. And we multiply by the derivative of what's on the inside, as usual. Okay, so now we have, take the derivative of sine, we get cosine, and let's just go ahead and replace these back with the standard variables that we have. So we have cosine of a times g of b comma c, and we're multiplying by, okay, well here we have to do the chain rule, or no, product rule, so pi 1 prime times g of pi 2 pi 3, plus pi 1 times g prime evaluated at pi 2 comma pi 3. So we have to figure out a way to evaluate g prime at pi 2 comma pi 3. Well, let's see here. So what are we going to do here? We're going to take this as, so this is cosine of, again, a times g of b comma c. And pi 1 prime here, so this is 1, 0, 0, times g of pi 2 comma pi 3. So I can just write this as, here, I'm going to write this as this. This is just going to be g of b comma c, 0, 0. Because that's what happens when you take 1, 0, 0 and you multiply by g of pi 2 comma pi 3. You just end up with this. And then what we have here is we're going to be taking, so pi 1 is going to give us a, and now normally when you're looking at, okay, well we've got g of pi 2 comma pi 3, well what this really is this is just, we're taking the derivative of g as a function of b and c. And we know how to do that because we know what the derivative of g is. We use the formula from before. So this gives us, so we have cosine of a times g of bc times, now we've got g of bc, 0, 0, plus, okay, so now we have to write this whole thing. Now, remember, we're taking g prime with respect to, when we're taking g prime here, we're actually doing it in 3 variables, so we can just sort of, so we have the a there still, and now the first variable is going to be 0 because there's no a inside here, because it's just g prime of b comma c. And then you can put the derivative of b comma c as separately in these final 2 coordinates, so this will become here cosine of And then what we do is we just rewrite the formula for G prime, and we replace A with B and replace B with C. So I'm going to write this on the second line because I don't think I'm going to have enough room. So it's A times, and now we have cosine of B sine C, comma. Oh wait, no, we had that 0. 0, comma, cosine blah blah blah, comma, cosine of B sine C, B cosine C. Alright. Here we go. Okay, so what this ends up with is, so we've got this cosine here. Let's see, so the first thing, this is going to be cosine, and then A times G of BC, that's cosine of A sine of B sine C, so that stays there, times, and the first coordinate here in this next term is going to be the G of B comma C, which we get from that first term in that sum. So G of B comma C, that's, remember, that's sine of B sine C, because that's what G of BC is. So that's the first coordinate. The second one is we've got, here I'll write the second coordinate on the second line. The second coordinate is A times cosine of B sine C times sine C. The third coordinate is A cosine of B sine C, B cosine C. And there we go. If you really wanted to, you could multiply this whole thing out further, but like, I don't think you'd really gain much from that. You just get a whole bunch of sines and cosines together. But yeah, that's about it. So this is how you do part D. And again, we've done it in a way that allows us to apply part C. And so yeah, we're done with this part of the exercise.